All right, here's an example from section 5.5, Foundations of Math 30. This is the conditional probability section, and this is number 5 in your textbook on page 351 if you're following along this course. So here's what the example looks like. It says there are 80 males and 110 females in a graduating class at Kelowna. Of these students, that's important, 30 males and 50 males plan to go to UBC next year. The question is, determine the probability that a randomly selected student plans to go to UBC. Okay. So, you look at that and you say, oh, well, there's 30 males and 50 females that plan to go to UBC. Well, it's not as simple as that, because there are 80 males and there are 30 of them are going to UBC. So there's two levels here. There's some conditions, right? You could meet any guy and there would be a certain probability that he would be going to UBC, and you know that's 30 of 80, right? But what if you meet a girl? Okay, well, you got to take into that consideration that there are not an even number of guys and girls. So anyway, so we're going to do our factor tree here, and you know me, that's what I like doing is the factor trees. So let's start off with the first sort of tree. Now, are we going to start off with males that go to UBC, or are we going to start off with just total males? You're going to start off with total males because this number right here, right, this 30 and this 50 are of the original students that are at the school. So yeah, so we're going to go back here, and the first level then is going to be male, and here are female. So what are the chances that we'd run into a male or female? Well, for male, there's actually 80 males, but since we need to talk about probabilities here, it's 80 out of, well, 80 plus 110. So 80 out of 190. And for females, there are 110 out of 190. So right away, you've got these two numbers here, the probabilities that you'd run into male or female. Now of those, so that's important, remember I said that was going to be important, of those students, 30 males go to UBC. So let's go to the males here. And then here, right, there's UBC, and down here, not UBC. And so what's that? Well, the percentage of these males that go to UBC, or the probability, is 30. Now, is it going to be out of 190? Nope. This part says 30 out of 80, out of the total that are male. So there's our second conditional probability there. So we've got 80 of the total and 30 of them, 30 of the 80 are going to go to UBC. So if we care here, we don't really care about this, but this would be 50 out of the 80 are not going to go. And then for females, right, so UBC and not UBC. For the females, it says that 50 females, so 50 of the 110. 50 out of 110. Right, and then there's 60 out of 110 down here. Okay, so I hope you're following so far. If we do the tree diagram, it's pretty easy to identify the levels, and then you can easily also identify the probabilities we're looking for. So the probability here, now what does the question say? Determine the probability a selected student plans to go to UBC. So here's the probability of a male and going to UBC. And that's here. And so way down here is the probability that you'd find a female that is going to UBC. So if it's a randomly selected student, we have to consider both genders. And here you go. We can find this probability. And then when we're done with that, it's either or, right? So we're going to do or, then we need to add those up. So we'll do that real quick. And actually, why don't you pause right now and see if you can get the final answer here, what the probability is for A, and I'll show you in 2 seconds. Okay, so here we go. If we multiply these probabilities, one over here and one over here, you should get in decimal form, I just wrote it down, about 0.1579. And over here, you multiply these two probabilities, 0.26316, and you add those up, and you should get your answer here of the the total probability that a randomly selected student, either male or female, would be attending UBC. Add up the individual probabilities, you get 42%. So we're going to take a look at B here as well. B says a randomly selected student plans to attend UBC. So a randomly selected student is already attending UBC. Determine the probability that the selected student is female. All right, so for this one, I certainly would go back to our tree diagram. And I'm just going to go back up here for a second. And so we're going to meet a student that is going to UBC. So guess what? These are the students down here that are not going. So we don't really care about these probabilities. We're looking at these ones. So the student that we're going to run into, right, that plans to go to UBC is this. We've already determined that to A. The question says, determine the probability that that selected student is female. Well, you can see that this probability here, the 42%, was made up of males that are going to UBC and females that are going to UBC, right? So if the total probability is 42, we can take a look at what makes up that 42. Well, about 26% that are female of the 42, right? It's 26. So we need to consider the fact that we have 42% that are going, and 26 of those 42 then are going to be female. So that's how we do B. So the probability that we have a female going to UBC, right? We want to take that and divide that by the probability of females that are going to UBC plus the probability of the males going to UBC, which turns out to be 0.263, that number, divided by the 0.42. So you get a probability that the student that you meet that's already going to UBC is 0. Okay, so if you look at this formula here, you can relate what we did in B to this formula here. Now this formula says that what's the probability that, and B would be what's the probability that we run into a female given that the person we run into is going to UBC, right? A randomly selected student plans to go to UBC, determine the probability that the selected student is female. So what's the probability that we run into a female given the student is already going to UBC? And this formula, even though it's a bit, I don't like using the formulas all the time. I like using just some intuition during these questions, but this is what we just did right here. This is what we just did. This right here, the probability of A and B, that's the probability of a female that is going to UBC. F and UBC. And divided by the probability that of all students going to UBC. So the probability that a student we run into is going to UBC. And that's what we did in A. And this is how we found it in A. Right here, you see? So it's not that earth-shattering. This is exactly what we did. And we just did this, 0.263 over 0.02 to give us this number. So this formula, I think if you relate it to questions like this, yes, it makes some sense. Would I, need you to go right to this formula and fill things in? No. It's going to take some work to get this one anyways, right? So we did an A. So I just want to show you that the formula, does work. So. Anyways, hope that helped.